Hey guys, this is our lesson 8.11 video. Please make sure you're studying for the test, which is Thursday. Here we go. So we have an investigation. It says the local parks department wanted to get an idea about improvement preferences for members of the community who use the park. On a weekday morning, the following data was collected at the park. Which of the following can be inferred about the entire population of park users using the data collected? Prove your answers with math. So, we have up here the things that people want and then how many people picked them, but we don't have the total. So let's go ahead and find the total in the survey. To do that, we need to add. So 25, 50, and 48. It's going to give us 13, so 3, 5, and 8, 123 people. So for each one of these, we're going to see if it's true or false. So most people want new tennis courts. If we look at the table, we have 50 people looking for new tennis courts. That is more than the other ones, so that one is true. Then we have more than half of the community wants new tennis courts. So here we're thinking, is 50 out of 123 more than a half? And I'm actually going to go with false because I know 50 out of 100 is equal to a half, and since this denominator is bigger, that whole thing is going to be false. Next one, we have about twice as many people prefer bike path to new swing sets. So let's see, bike path is 48, new swing sets is 25. I'm going to say that one's true because I know 25 times 2 would be 50 people, and 48 is close to 50, and it says about twice. So because that about is there, that one is true. Last one, fewer than 50 park users want either a new bike path or swing sets. When you see either or, you need to add those two things. So bike path was 48 and swing sets was 25. So if we add these, we get 73. Is 73 fewer than 50? Nope. So we should go true, false, true, false. So key points for today are going to be pretty general because since we have that test Thursday, we are kind of just reviewing everything. But anytime you have data, you can use it, like we just did in our investigation, to make a prediction about a population. So all I had here was the sample, but we assumed that that was similar to our population and we made these predictions. We can always use a proportion to do this. I know we didn't show that yet, but we will. One side represents the sample, and the other represents the population. Then if we have a question with a percent, just remember that that goes out of 100. So if I wanted to know what percent of people, I could say my sample out of my total equals what percent out of 100. So that's kind of how that would look. And then last thing, if you have a proportion, just remember your two steps are to cross multiply and divide in order to solve that. All right, so let's look at our last example. We have a chart that shows the number of students in Ms. Shipman's freshman math class who were born during each month of the year. Which of the following can be inferred about the entire population? So option A says none of the freshmen in the school have a birthday in July. They think that because if we look over here at July, we have a 0. However, it's really, really, really unlikely that none of the freshmen in the school have a birthday in July. So this one, no. There's probably at least one. We just didn't get that person in our sample. All right, the months with the least number of students born in is November. So let's look. November over here has 1. We also see October has 1. And March has 1, so this one is no, because March and October are the same. All right, and obviously we had our weird July situation. All right, next, we have more than half of the freshmen will have a birthday during the first 6 months of the year. So if we tally up, we need to know the total here for the first 6 months and the entire total. So if we add up just the first 6 months, we have 4, 7, 8, 14, and 24. And then we have 2, 6, 7, 8, 11. So our big total is 35. And 24 were in the first half of the month. So this one I think actually, yes. And again, our math here is 24 out of the 35 is greater than half. All right, last one. About 15% of the students will have a birthday in December. So here's where we can set up a proportion. We know December has 3 people out of the 35. This side is our sample. And we're saying, is that 15%? 15%, we know percents go out of 100. And so we're just going to see, is this true? If we were going to get from 3 to 15, we would have to multiply by 5. So we're just going to see, is 35 times 5 equal to 100? And nope, we went over. So part of this is an about, so it's an estimate, but this is like way over 175. That's almost like twice as much. So let's say on this one, no, it's would be less than 15%. So that leaves us with answer choice C. So I know that was a lot of thinking and talking through that, but when you guys have these type of multiple choice questions and they're about predictions, make sure you're always looking back. Usually you'll need to find this total and then read the questions really carefully. It might be comparing different things. You might have to set up some type of proportion to find out something about your population. So take those skills, get going with your practice, and then good luck on your test Thursday.